Hello everyone, so today we're going to go over sections 8.1 and 8.2, multiplying integers. So we'll be using counters, these two here. So the yellow counter in our notes will be +1 or +1, and the red counter will represent -1. So a pair of yellow and red counters will be +1 plus -1, which of course is equal to 0. And we'll be using these to multiply integers. So we'll begin by multiplying integers using counters. The first integer indicates how many groups to add in or take away. So if the first integer is positive, then we add in that many groups. If it is negative, then we take away that many groups. Okay, so here we have our first example. So we have +2 multiplied by +3. So we add in two groups, and each group contains three positive counters. So for a total of +6 or +6. Okay. Likewise, in the second example, we have +3 times -2. So we're going to add in three groups of -2 counters in each group. So we're going to use the colors from the beginning of the notes to represent negative counters. So -1, 2, 3, 4, 5, and 6. Okay. So of course the product then will be -6. Okay. It's going to draw a negative sign in each one of these counters to indicate that they are in fact negative. And once again, the product is -6. We count the total number of counters at the end of the multiplication. Okay. So now we have an example where we start with a negative integer. So in this case, -3 times +2. We're going to try to take away three groups, two positive counters in each group. So in order to do that, we will begin with some zero pairs here. Notice that the sum of all the counters in the box on the left is equal to 0. So we added in 6 positive counters and 6 negative counters, and that way we can take away the 6 positive counters. And the result is we're left with 6 -1 counters, so the product is -1. Sorry, -6. Okay. So in the next example, we have something similar. We have -2 times -4. So it says to take away two groups, and there are four negative counters in each group. So in order to make that work, we need to start with some zero pairs. So we need to start with 8 zero pairs. Right, so take away two groups of -4 counters each. Something that looks like this. So once these 8 counters are taken away, we're left with 8 +1 counters. and so the product will be positive 8. Okay, so to complete the question here, simply 8 positive 1 counters. Okay, so this is how we can use counters to represent multiplication of integers. Next, we are going to use a number line to multiply integers together. Alright, the first integer indicates the number of hops we take and the direction we face. If the first integer is positive, we'll face to the right. And if the first integer is negative, we face to the left. So this is of course true for the general number line. The second integer in our multiplication indicates the number of steps in each hop and the direction in which we hop. So if it is positive, the second integer, then we will be hopping forwards, and if it is negative, we hop backwards. Okay, let's see how this will work in our examples. So let's start with example number 5. We'll model positive 3 times positive 2. So that will be 3 hops to the right, and each hop is going forward. So in this case, we're going to draw a stick figure who is facing right. And so this stick figure is taking 3 hops to the right, and each hop is of size 2. So go from 0 to 2 in the first hop, 2 to 4 in the second hop, and finally 4 to 6 in the third hop. And of course, each hop is positive 2, positive 2, positive 2. So it will give us a product of 6, or positive 6. All right. So what if some of the integers are negative? So suppose we have positive 3 times negative 2. We are taking 3 hops to the right, but each hop will be backwards. So we are once again going to start from 0. We're going to face the right, but we're going to hop backwards. So starting from 0, facing right, hopping backwards will take us to negative 2, then negative 4, and finally negative 6. So in this case, then the product is negative 6. Each hop is minus 2, or negative 2. Okay. In example 7, we have negative 3 times positive 2. So we have 3 hops facing left, and each hop will be forwards, 2 steps forward per hop. So again, we start at 0, but this time we're going to have 3 hops facing left, and it's going to be forward. So negative 2, negative 4, negative 6. So notice that in examples 6 and 7, we have the same product, but the questions, of course, were different. So this is once again negative 6. And finally, what if both integers are negative? Then we have in example 8, 3 hops facing left and going backwards. So we're going to face to the left. But if we're hopping backwards, oops, sorry about that. It's going to go this way, 2, 4, and 6. Right, so it will take us to a product of positive 6. So yeah, so imagine if we have the stick figure person facing left, and hopping backwards would take us to +6. Okay, so to summarize the result from both the counters and also the number line, we can now multiply integers without using a model, using the sign rule. Now here, if we have product of two integers with the same sign, then it will be positive. That is to say, the product will be positive. So either if both integers are positive, the product will be positive, or if both integers are negative, then the result will also be positive. However, if they have different signs, then the product will be negative. Okay. So with that, you can find some products here. First case, +3 times +4. The result will be positive. In this case, 3 times 4 is 12. Next up, +2 times -9. The result will be negative since the two numbers have different signs, so we have -18. Example C, likewise, it will also have a negative product, in this case, -30. Notice that -5 and +6 have different signs. Example D, both numbers are negative, so the product will actually be positive. This will be +24. Next up, we have +28. And now, since the first integer is positive, +3, and the second one is negative, -10, we have -30 as a product. From there, +16, since both numbers are negative, they have the same sign. -36, the numbers have different signs. And if we have something like example I, where we have more than two integers being multiplied together, then we will take this one step at a time. So first, 4 times -3 is going to give us -12. And then from there, -12 times -2 will give us +24. Or just 24. Okay. Next part is just a quick reminder. We can always write repeated addition as a multiplication. So in this case, we have -3 plus -3 plus -3 plus -3 4 times. So as multiplication, this will simply be 4 times -3. And likewise here, this will be 3 times +5, or just 3 times 5. And of course, if we wanted to find the product of each one, the first one will give us -12, and the second, +15. From there, if we are to write these multiplication as repeated addition, the first one would be -6 plus -6 plus -6 plus -6. And in the second case, we have -9 plus -9 plus -9. Okay. And now we're finished with a few quick word examples. Tina supports her favorite charity with an automatic deduction of $35 per month from her bank account. Calculate her total deductions in a year. So this would be simply $35 per month multiplied by the number of months in a year, which is 12. So we will have 35 times 12. The result will be $420. Okay, the temperature in Toronto dropped by 3 degrees Celsius each hour over a period of 6 hours. What is the total change in temperature? Right, so in this case, -3 degrees per hour. And this trend continues for 6 hours. And this will give us a product of -18 degrees Celsius. Okay. Finally, last example, Dwayne owns 325 shares of Global Tech Media. Each share decreased by 33 cents over the period of 1 week. If this trend continues, what's the total change in value of Dwayne shares in 8 weeks? Okay, so one of those has a little bit more, or is a little bit more involved. So we have 325 shares. Multiply by -33 cents per week. And this trend holds for 8 weeks. So something like this, we can probably just use a calculator. Okay, let's go ahead and do that. So 325 times 33 is 10,725. And then we multiply that by 8. Okay, so the product will be 85,800. Now, this is actually in cents. So in order to convert that back to dollars, we divide by 100. So we will have $858 loss. Okay. So these 3 examples are meant to give us an idea on when multiplication can be useful. So today we went over how to multiply integers using counters, using a number line, and move out any models. And that's it for today. So thank you for listening.